Hi, welcome back to my YouTube channel. This is Yong K Soon. Today is milestone number 5, which is the final milestone, whereby I will put everything together and make a summary of the entire project. But first, let's revisit our objective. Okay, there are a few objectives here. The key objective is to predict that the stock market for a particular stock, the closing price will be higher in the next business day. The scope is within KLC Stock Exchange. The use of this is to help the short-term investor, like the day traders, for them to beat the market using machine learning. We have exploited multiple data mining techniques that requires to transform to load, to analyze, and to present the data. Right? And the whole thing is stored into a data warehousing technology, which I will show you later. Okay. So very quickly, the agenda of this short video will cover very quickly from data acquisition to cleaning the data, storing into the warehouse, analyze it from the data in the warehouse, and process it for machine learning and the final conclusion. So everything will be available through GitHub for download. Let's look at the entire system that I built. We have crawled multiple data sources, Twitter's RSS sources for news, business news, stock prices, news available from the websites, and also the web forums. So all this is captured through a scheduler that we built using Python. This Python script will crawl data every night and store it in the temporary staging area in Google BigQuery storage. So what we did is we further transfer this data, clean it in a way, and put it into our enterprise data warehouse built on top of Hadoop and Hive. So our visualization tools that I'm going to demonstrate later on how to visualize the covariance and sentiment analysis. The tools that we're using was Tableau, Power BI with some R integrations. So the visualization tools, the BI tools will will get the data from warehouse for visualization. After that, I will also show you how we process the data, clean the data, transform the data to a way that machine learning can use for predictions. And by the end of these videos, I will show you the result of the predictions. Let's go through this again. This was covered in the last milestone video, but a quick recap. All the data sources, some of the data sources we didn't use, like Twitter, there are too much noise, so we discarded the data set. We updated the model from 2nd March until just 2 days ago, 10 May, very recent data. And we will perform joining, we will perform cleaning, fill up the missing values, and we scale, and we tested with a few models. Okay, we have tested. I have tested stocks from A-shares and also combination of a few other stocks. Right. Let's proceed on. So very quick recap. This is how we join the data from various data sources. We join and make it a final data set, which is one row. One row represents one day, one stocks, and their relevance features. All the various data sources are populated through as the columns as features. All right. Missing data is treated using various techniques, using backward fill, forward fill, interpolate, or in between missings you do interpolate. The front missing you use a backward fill, the last missing you use a forward fill. And we introduce a few additional features. Moving average, 3 days moving average. We converted the day of the tradings into binaries, 1 and 0 represent different days. And the scalings that we used was min-max. All numbers, numerical numbers, are scaled to min-max. And sentiment analysis, the news headlines is translated to English, and we use an LTK to represent it in the polarity. It's positive news or negative news, and there's relevant strengths. let's look at the sentiment analysis. Based on these few stocks, Asia, Airport, until Top Glove, these are the few more active stocks that has news headers published. That's why they are picked for this study. So we see that actually the positive news and the negative news we have averaged out the polarity and we correlate it to the predictability of the next day price going up or down. So we see that for Ecovest and Genting, there are some gaps, means there are some differences that we can hope the machine learning will pick up. But for majority of the stocks, even like Asia, there's really the polarity doesn't differentiate enough between the price going up and down. The class that we are looking at, it doesn't really differentiate, right? Anyway, we shall see. I also perform a covariance correlations analysis for this particular stock, Asia, and for many other stocks as well. Realize some of the features are very highly correlated, especially the very dark dot here. This is understandable because the percentage change and actual change value is actually hand in hand, it's derived by each other. So some other things that correlate very well together are this one is the currency exchange. So they all move together. So the one they use is CNY, Chinese yen, Sing dollar, and USD. So we can reduce it to just one currency, and the percentage change we can remove it. We can maintain just the actual change value. So this will further simplify our features. Okay. Next, let's look at our machine learning model metrics. What we're looking at here is a confusion matrix. What we are really interested in are the box in red here. So we are interested in true positive over the true positive plus false positive, or in short, we call it precision. So we wanted to maximize that we correctly predicted the stocks goes up, right? We are not interested in the predicted negative because we don't actually lose money here. Okay, we only lost money if we wrongly predicted that it goes up. Okay, so these metrics called precision is precisely what we are going to maximize our model with, right? So with this objective in mind, let's move on to our modeling. There are two methods of modeling that I will be trying. The first one is the common train test split modeling, where you train all your data, 70% of data, and then to predict the 30% of the data. So I will use that as well and compare with another method of modeling. I call it the progressive modeling, whereby we predict only based on the training data. We only predict one day, which is next business day, and we shift our window size of the training data on the next day, and on the next day we shift our window size again. So we could have figured out what are the window size, what are the best window size that we can use to maximize our precision score. Okay. Right, so let's look at the result. Okay. It turns out we have tried two machine learning algorithms. Extreme gradient boost will give us, on Asia stocks, it gives us about 50% precision, which is really nothing to shout about because it's almost like gambling. Logistic regression is even worse. It's only 33%. However, using logistic regression on the progressive mode, where we fix the window size and we progress over the time series, it gives us very good precision, which is 66%. And then we look at combine multiple stocks together, so we can get more data and see whether the models will give us better results. So we combine multiple stocks together, Asia, Genting, Kamura, and Airport. The model gets worse for SG Boost. In fact, for logistic regression, it gets 0% precision. It's very likely that the model keep predicting is negative, so you don't get any precision here. But however, if we use the progressive method, we get a stunning 71% precision score. Also quite impressive over the 29 days windows. Okay, so how do I do that? I'm going to share with you one snapshot of how AirAsia perform. This 66% perform. So how I discover that 66% is the maximum precision score when we choose a window size of 37 days. Okay, I've constructed the Python scripts to run through a scan of the different window size, and this is precisely what I get. Right? What it means is based on our prediction, there are 15 days of test data. The model predicted 6 positive, 1, 2, 3, 4, 5, and 6. But out of these 6 predictions that the price will go up, only 2 are wrongly predicted. This gives us the precision score of 66%. Right, so it's quite positive. When the machines predict that it goes up, we have 66% confidence that the machine is right. So based on that in mind, this is what I will recommend. Okay. In Malaysia, we have total trading days of 261 days. And we know that based on the small data frame, we know that 40% of the time the machine will make a positive prediction. 40%. That gives us 104 days to buy stocks, to buy Asia. And if we expect to make 1% on the successful trade, we assume we could make 1% successful trade, and we know that the precision score is 66%. After contra with the losses of wrong prediction of 34%, it means our chances of making 1% profit is 32%. Okay, it's 66% minus the wrong prediction 34. We get 32% net. All right. So over a year of 104 days of buying days, 104 buying days, positive prediction days, we can make a net profit of 33%. Okay, 33%. So that's how the formula works, right? But of course, there are few key catch here. Of course, number one is the data is small. This Asia, we only get 2 months of data, and based on this small data, we only see that 40% of the time the machine managed to predict positive. Okay, and we are saying that we're going to make 1% every time you trade, but sometimes the opening price itself is really more than 1%. You may not have the chance to buy at the price at the yesterday close price. You may not always have the chance to buy yesterday close price. And you must be able to sustain the consecutive losses and take your own risk, right? Take your own risk. Lastly, the whole thing is available for download. Every codings, the Tableau workbook, Power BI workbook, which I forgot to show you. This is the Hive servers, Hadoop Hive servers that I'm using. And to connect to these servers from Tableau or Power BI, you need to install a driver here, ODBC driver, just to do a quick test. A quick test that the driver is able to connect to the Hive servers. And the Tableau, this is where you can get the data sources from. This is Tableau. You can get the data from the Hive server for the visualizations. It's trying to grab it. And same goes to Power BI. Power BI is able to do a collaboration chart. This is integration with R programs, libraries, right? So it's quite nice. Okay, so that's all I have today. I hope you enjoy the video and hopefully this is useful for you. Thank you so much.